Hello, myself Kumbhare, Associate Professor, Department of Chemistry, DBF Dayanand College of Arts and Science, Solapur. Today we see about synthesis and industrial applications of petrochemicals. So many petrochemicals are there. We here see its uses, what are the synthetical methods, and how these petrochemicals are applied. Firstly, we see about ethylene oxide. This is the structure of ethylene oxide, CH2CH2, and the both carbons are bonded to single oxygen by using the oxide ring. Synthetical method. So see the first synthetical method. Industrially it is prepared from ethylene. Ethylene and air are passed over hot catalyst. So this is the CH2 double bond CH2 is ethylene plus half O2 moist silver catalyst. There is a formation of ethylene oxide. So this pi bond is broken and this oxygen is bonded to both carbons. Second method is ethylene oxide is prepared by distillation of ethylene chlorohydrin with KOH. See, this is chlorohydrin reacted with potassium hydroxide. So firstly the KCl is removed from chlorohydrin and KOH, and OH from KOH and the hydrogen from CH2OH, removal of water molecule, and this oxygen is now bonded to this carbon. Already this is bonded to one carbon, and now after removal of KCl and removal of H2O, this oxygen is bonded to another carbon. So this is ethylene oxide. See the uses of this ethylene oxide. This ethylene oxide is used as an insecticide. Ethylene oxide is used in laboratory synthesis. So many other chemicals are prepared by using or starting material as a ethylene oxide. Ethylene oxide is used as a starting material for the production of cellosols used in industrial solvents for cellulose. So this is one of the solvent, and for this solvent ethylene oxide is the starting material. Also this ethylene oxide is used for the preparation of ethyl glycol, other glycol ethers, and many chemicals. So this is one of the petrochemical, ethylene oxide. We saw here two synthetical methods and the applications or uses of this ethylene oxide. Secondly, we see the adipic acid. It is also a petrochemical. The formula for this adipic acid is COOH CH2 4 times COH, which is a open chain or straight chain compound. Synthetical method. Phenol on catalytic hydrogenation gives cyclohexanol, which on oxidation with nitric acid gives adipic acid. So this is the phenol aromatic compound. Its catalytic hydrogenation, that is phenol is unsaturated, and after catalytic hydrogenation it becomes completely saturated compound, which is known as a cyclohexanol. And this cyclohexanol on oxidation with concentrated nitric acid forms the open chain or straight chain compound having two carboxylic acid groups, that is diabasic acid, and known as adipic acid. This is the first method. Then in second method, cyclohexane on catalytic oxidation gives cyclohexanon or cyclohexanol, and this on oxidation gives adipic acid. So cyclohexane is prepared from benzene. So again this benzene on catalytic hydrogenation, benzene is unsaturated, and after catalytic hydrogenation with sodium it gives cyclohexane. This cyclohexane on oxidation either gives cyclohexanone, that is ketone, or cyclohexanol, which is alcohol. And this cyclohexanone or cyclohexanol on oxidation gives adipic acid, that is diabasic acid, open chain diabasic acid. Also, this cyclohexanol is converted into cyclohexanone by oxidation. And this cyclohexanone again oxidation gives adipic acid. So these are the two methods of preparation of adipic acid. Now we see its uses or synthetical applications. It is used as an intermediate in the manufacture of nylon. So for manufacture of nylon, this adipic acid is an intermediate. Also, this adipic acid is used for the production of ester plasticizers such as dioctyl adipate. Adipate is the ester. Also, this adipic acid is used in the manufacture of polymethane rubbers. So there are many varieties of rubbers. One of this is polymethane, and for this production of polymethane, this is the starting material, that is adipic acid. And also this adipic acid is used in the preparation of resins. So production of resin is also done by using adipic acid. Then we see the third petrochemical, that is styrene. C6H5CH double bond CH2 COOH. Preparation: styrene is obtained by dehydration of 2-phenyl ethyl alcohol. So this is the starting material. This is the phenyl ring, which is attached with CH2 double bond CH2OH. So this is 2-phenyl ethyl alcohol. It is heated in the presence of alkali. So there is a removal of water molecule, that is OH from this carbon and H from this carbon, the carbon which is attached to the ring. So carbon which is attached to the ring loses hydrogen and another hydrogen loses OH group. So there is a removal of H2O and formation of styrene. Another method, benzene on reaction gives ethyl benzene, which on catalytic hydration gives styrene. So see, this is the benzene reacted with ethylene. This is the addition reaction. So there is a formation of phenyl ethane, which on catalytic hydrogenation using ZNO, zinc oxide, at 873 Kelvin, it gives styrene. So for this styrene catalytic hydrogenation, one hydrogen from the carbon attached to ring and another hydrogen from next to carbon or adjacent carbon. So there is a H2, removal of H2 and formation of styrene. It is used in the manufacture of plastics and synthetic rubbers. So many plastic varieties, hard or soft plastics, hard or soft rubbers. So good quality of rubber is produced by using this styrene, because natural rubber is having some defective characteristics. So by removing these characteristics, a good quality synthetic rubber is prepared from giving styrene, that is buta-N, buta-S, buta-N, buta-S. These are the synthetic rubbers which is prepared by using styrene. Fourth petrochemical is 2-phenyl ethanol, which is also known as beta-phenyl ethyl alcohol. Formula is C6H5CH2CH2OH. See the synthetic method. Reaction of phenyl magnesium bromide with ethylene oxide followed by hydrolysis gives 2-phenyl ethanol. Bromobenzene reaction with magnesium firstly gives it phenyl magnesium bromide, which is reacted with ethylene oxide, formation of addition product, and then on hydrolysis it gives 2-phenyl ethyl alcohol. This is the one method. Second method, it is prepared by reduction of phenyl acetic ester with sodium in alcohol. So starting compound is phenyl acetic ester. It is reduced by using sodium in alcohol and it gives 2-phenyl ethyl alcohol or beta-phenyl ethyl alcohol. It is used as a sweet smelling oily liquid which is chief constituent of rose oil. So for the production of rose oil, this beta-phenyl ethyl alcohol is used. Then the alcohol and its esters are used in the preparation of perfumes. So many artificial perfumes are prepared by using this 2-phenyl ethyl alcohol, and its amine is also used in medicine. So amine prepared from this alcohol is useful for the production of medicine. And one more petrochemical, that is paracetamol, which is also known as acetaminophen. See the synthetical method, a para-nitrophenol on reduction gives para-aminophenol, which on acetylation gives paracetamol. So the starting compound is para-nitrophenol, which on reduction, that is nitro group is converted to amino group. So it is para-aminophenol. And this para-aminophenol on acetylation by using CH3CONA. So there is a acetylation of this amino group and convert it into NHCOCH3. So this is N-acetyl para-aminophenol, that is paracetamol. And its uses, it has analgesic and antipyretic activity. So this paracetamol is used in analgesic to relieve pains and antipyretic to lower the temperature of the body. So it is analgesic and antipyretic. It is used by various trade names like crocin, metacin, etc. So in the market, this paracetamol is sold in the trade names crocin, which also having paracetamol. Metacin is also having paracetamol, and it is also marked in combination with aspirin and caffeine. Aspirin and caffeine combination, it is marker for this paracetamol. So these are the uses. So we saw some petrochemicals, what these petrochemicals are prepared or synthesized by various methods, and its synthetical applications or uses. Thank you.